Alright, in this first day, we're starting a new section and we're going to start to talk about product rules and quotient rules and higher order derivatives. So to get started with this, let's go ahead and talk about what is a product rule, what is a quotient rule. A product rule can be used anytime you have two functions that are being multiplied together. We've seen this before in prior assignments, but what we did to deal with this was instead of using product rule, we just FOILed this out, then took the derivative. That's fine, you could still use that method. I probably would in this particular case rather than using product rule because it's simpler. But what product rule says is anytime you have two x's being multiplied together, what you can do is take the derivative in this manner. You do the first times the derivative of the second plus the second times the derivative of the first. And you'll see this in examples. And those are the words I'm going to use. First times the derivative of the second plus second times the derivative of the first. The second rule we're talking about today is quotient rule. And I'll describe this as bottom times the derivative of the top minus the top times the derivative of the bottom, all over bottom squared. Now this would be something where you had like x plus 1 over x plus 2, and you had to take the derivative of those. So you'd have bottom times the derivative of the top minus top times the derivative of the bottom, all over the bottom squared. The other parts we're going to talk about, and you need to memorize the rest of the trig functions. The derivative of tangent x is secant squared x. The derivative of cotangent x is negative cosecant squared x. The derivative of secant x is secant x tangent x, and the derivative of cosecant x is negative cosecant x cotangent x. If you remember, the derivative, you guys should have memorized this already, the derivative of sine is cosine of x, and the derivative of cosine of x is negative sine of x. So anytime you have cosine, cotangent, cosecant, notice how all those derivatives are a negative value. The other part of this section is we're going to start to talk about higher order derivatives. All that means is that instead of finding just the first derivative, I may ask you to find the second derivative, third derivative, or the fourth derivative. Well, the way you find your second derivative is by taking the derivative of the first derivative. So basically, you're deriving the function twice. If you want the fourth, you're doing it 4 times. I just want you to pay attention to all the different notations. So the first derivative is y prime, and the second derivative has a double prime, third triple prime. This one, you put parentheses around the 4 rather than making 4 primes. The reason why we put parentheses around it is so we don't think it's y to the 4th power. The same thing occurs with f prime of x, f double prime of x, and so on. Then we have dy over dx, which says we're taking the derivative of x, or the derivative of y with respect to x. If you have 2's or 3's or 4's, that's just indicating the number of derivatives that are being taken. This says take the derivative of the function with respect to x. This one says take the derivative of y with respect to x. Notice that there's just numbers that correspond with the different derivatives. Looking at this first problem, we can use product rule on this. And I'll go ahead and use product rule first, but then I'm going to show you how I probably would have approached this problem, only because I think it's simpler. Product rule can be used on this because two things multiplied together. This is s to the 1/2 power. That's how I'll denote it. So g prime of s would be first, the first part. I'm going to go ahead and change colors. I'll do first and second. So I'll say it's the first function times the derivative of the second function, which would be 2s, plus the second function times the derivative of the first function, which would be 1/2 s, lower that one by 1, negative 1/2. So this actually gives me 2, this is 1, so I add those exponents together, s to the 3/2 plus, if I distribute this out, I'd get 1/2, negative 1/2 plus 2 is 3/2. That's what we do when we have something with the same base. We add those exponents, plus, this would be half of 8 is 4, 4s to the negative 1/2. I'm going to leave my answer like that for right now to see how it compares to what we already know. If I was to do this problem, I wouldn't use product rule. I'd just use the old-fashioned, let's distribute this and get s to the 5/2 plus 8s to the 1/2, and now let's just take this derivative. You get 5/2 s to the 3/2 power plus you get 4s to the negative 1/2. This is the correct answer, and so is this. And you might be wondering how they match up. Well, these are like terms, so we actually have 5/2 s to the 3/2 plus 4s to the negative 1/2 right here. Same answer. As I said, pick the easiest way to do it. Sometimes you have to use product rules, sometimes you can FOIL or distribute stuff out and get away with not using it. Alright, in this problem I said in the last video we would do a quotient rule, and this is a quotient rule, and I know it's quotient rule because I've got t's being divided by each other. Quotient rule says this. It says I take the bottom function times the derivative of the top function, which would be negative sine of t, minus the top function times the derivative of the bottom function, which would be 3t squared, all over the bottom squared. All I can really do is rewrite this just a little bit. I could say this is negative t cubed sine of t minus 3t squared cosine of t all over t to the 6th power. The next problem, it's asking me to find f prime of x and f prime of c. Now, there's two ways you can do this. You could FOIL this all out. I'm not going to because it's going to give me 6 different terms, and I might be able to add some of those together, and then I plug in one. I'm just going to see if I can just use product rule to come up with my answer more quickly. So I'm going to denote this as first. I'm going to denote this as the second function. So I'm going to write first function times the derivative of the second function. And the derivative of the second function is 3t squared plus the second function times the derivative of the first, which would be 2x minus 2. If you want to simplify this, you can, or you can just leave it at this point and plug in 1. Just for today, I will go ahead and simplify it. Lots of times I'll leave this answer like this is. There's no reason to simplify it, in all honesty. We end up getting 3x to the 4th minus 6x to the 3rd plus 3x to the 2nd plus, I get 2x to the 4th, I get minus 2x cubed minus 2x and then plus 2. That's a mess. I'd have to put these together, which gives me 5x to the 4th. We get negative 8x cubed. I have a plus 3x squared, a minus x or 2x, and a plus 2. Now, as I said, this is really not necessary to do because I could have figured out what f prime of 1 is way up here just by plugging it in right here. So a lot of times there's no reason to simplify it. I just did it for today just because. Plug in 1 at this point. These give you 0, and here you have 5 minus 8, which is negative 3 plus 3, and so that ends up giving you 0 as well. Had I just done that way up here, plugged in 1, I would have seen I had 0 here. 0 times anything is 0. And if I had plugged in 1 up here, I'd have 1 minus 2 plus 1, that's 0. 0 times anything is 0. So I could have saved myself a lot of time, a lot of simplifying, just by plugging 1 back in much earlier. This is the last one I'm going to do on this particular video, and then I'll finish up on the next one. This is just one where we complete the table. So I'm going to go ahead and rewrite this. So this would be 4/5 x to the negative 2nd. I differentiate. This isn't really even a quotient rule. There's no reason to do quotient rule because there's no x up here. Just keep it the easy way. That's why I picked this problem. Just because we're learning quotient rule doesn't mean you always have to use quotient rule. So you get negative 8 over 5, lower it by 1, x to the negative 3rd. And so we could rewrite this as negative 8 over 5x to the third. On this problem, I said it was going to be my last one, but I'll do one more here. I would either FOIL this out or use product rule. In all honesty, I almost think it's almost easier just to go ahead and FOIL this one out rather than use product rule, but since we're learning about product rule, I'm going to go ahead and do product rule today. This will be first and this will be second. So I'll say first times derivative of the second. Derivative of the second is 2x plus the second times derivative of the first, which is 2x. And I could simplify it, or I can just leave it like this. And so I'm going to show you how you can just leave something in that form. Last problem for this section, I've got a couple things going on. I've got two terms, and within those, I've got two product rules. I've got first times derivative of the second right here, so I've got to do the derivative correctly there. And then here I've got a first term times derivative of the second here. So I've got two product rules within this one problem. So the derivative of h would be first times derivative of the second. The derivative of secant is secant x tangent x, and that's something you guys have to memorize. Secant x tangent x plus the second times derivative of the first, which would just be a 5. Now we're going to move on to the second product rule. So first times derivative of the second. Tangent, the derivative of the tangent is secant squared x plus the second times the derivative of the first. The derivative of the first is 1. I could simplify this just a little bit by maybe putting some things, making things look a little nicer. So 5x secant x tangent x plus 5 secant x plus x secant squared x plus tangent x. I guess that's really all I can do. None of them are like terms.